today we are going to start a topic from chemistry paper second, that is chemical kinetics. So I think in 12th standard you may have been studied this uh, chapter, that is chemical kinetics. So what is mean by kinetics? You may heard about the word kinetics for the bike name. So now see here what it mean exactly. So chemical kinetics deals with the rate at which chemical reactions takes place, means the rate at which chemical reactions takes place is calculated in terms of kinetics of these reactions. Therefore they have given the name chemical kinetics. So chemical kinetics deals with the rate at which chemical reaction takes place, the mechanism by which reactions takes place, and also the influence of various factors such as temperature, pressure, concentration, etc. on reaction rates. So in this topic we are going to learn exactly about the rate of reactions, their mechanism, and the factors which affect these reactions, the factors such as temperature, pressure, concentration, etc. Uh, a quantitative study of reaction kinetics has an important role in such diverse field as biochemistry, production of chemicals, medicine. So this field is more important for the research point of view. So in the field of biochemistry, while production of chemicals, while study of medicines, we must know exactly about the kinetics of such reactions in the body also. So every chemical reaction takes place at definite rate depending upon the conditions. So if you think about the different chemical reactions taking place in our body, after eating, after some time, the food is get digested. So in our stomach, in intestine, some different type of reactions are taking place. These reactions depends on different factors. So depending upon the condition of the environment, the food is get digested in the body. So the same thing is going to be happen outside the body also. In uh, when we study these reactions in lab, we must exactly know about what time it takes to complete the reaction, that is how the reactant is converted into product is calculated in terms of this kinetics of reactions. Some reactions are so fast as to be instantaneous, means within a fraction of second the reaction is get completed. We cannot understood, we cannot determine the rate of such reactions. They have given the example here, neutralization of HCl by NaOH. When you add HCl and NaOH, then within a fraction of second the reaction, that is neutralization reaction, is get completed. So you know this reaction HCl plus NaOH, so Cl minus and Na plus H upside OH. So neutralization of neutralization reaction takes place, and we are getting water along with the salt. So this is a neutralization reaction where the reaction is get completed within a minute. So for such reactions we cannot calculate the rate of reactions. In some cases the reactions are so slow that they take months to year to complete into the product. So such type of reactions, that is such the rate of such type of reactions we cannot calculate it. So some reactions are slow, some reactions are so fast. So between these two extremes there are reactions which takes place at moderate measurable rate at room temperature, and it is these reactions that are studied in chemical kinetics. So those reactions which are moderate and which are carried out at room temperature, or those reactions which take not a small time or not exactly the longer duration time, but those reactions which are moderate, they can be studied in term with the help of kinetics. If all substances taking part in a reaction are in the same phase, the reaction is said to be homogeneous. Means what? See here, if all the substances, suppose reactant A and reactant B, suppose A1 and B1, so these two reactants are in liquid phase, suppose these two are in liquid, therefore these reaction of such type of molecules are known as homogeneous because these two are in a same phase. If more than one phase is involved in a reaction, then it is known as an heterogeneous reactions. So if the phases of reactants are different, then it is known as heterogeneous. If phases of reactants are same, then the reaction is known as an homogeneous. So the next point is rate of reaction. So what is the rate of reaction? Uh, Now see here, the rate of a chemical reaction may be defined as the change in concentration of any reactant or any product per unit time. When reaction takes place, there is change in the concentration of reactant or there is change in the concentration of product per unit time. So that rate of change of concentration is known as the rate of chemical reaction or rate of reaction. So it is given if in a given case, suppose a reactant having a concentration C reactant at a time t, then now see here the rate of reaction is written by this equation, so minus dc upon dt. So what is meaning by minus dc upon dt? Now see here, C is nothing but the concentration of reactant, T is the time taken. So in time dt, how much amount of reactant concentration is changed is written in terms of dc. So dc is the small change in concentration of reactant with respect to the time, that is dt, the time. Suppose dc is the change in concentration in 1 minute, then we may write this equation as minus dc upon 1 because it takes 1 minute. So in this case the negative sign is there. Now see here, so this negative sign indicates that concentration of reactant decreases with respect to the time. As we follow the reaction, suppose we are taking a reaction in the morning 10 a.m. and the reaction takes place up to 12 a.m., then the time required for the completion of reaction is 2 hours. Okay, so suppose after half an hour, how much amount of reactant is changed into the product is calculated by use of this formula, that is rate of reaction is equal to negative sign of dc by dt. So the minus sign indicates that there is a decrease in the concentration of reactant, or on the other hand there is increase in the concentration of product. Suppose the concentration of product changes with respect to time x and t, then we can write this equation. Now see here, rate of reaction is equal to dx by dt. So now see this equation second, where the change in the concentration of product is dx by dt. Means what? Now see, if you see these two equations, in the first equation 1.1.1, the change in concentration of reactant is shown with the negative symbol, that is negative dc by dt. But in case of this product, the rate of reaction is shown as dx by dt. So the first equation, the negative sign indicates during the reaction the concentration of reactant changes decreases, but in case of product the concentration of product goes on increases. Therefore there is no negative sign in the second equation. So again I take a revision for the definition of this rate of reaction. So rate of reaction is nothing but the change in concentration of any reactant or any product per unit time. that is known as a rate of reaction. Okay. It follows from the above discussion that rate of reaction must have units of concentration divided by time. So the rate of reaction just we have uh, written there. So the rate of reaction is nothing but change in concentration with respect to the time. So the unit of rate of reaction must be the concentration per time. So the concentrations are generally expressed in mole per dm cube. So the concentration is always expressed in terms of mole per dm cube, or if gas is there, then it is expressed in terms of kilopascal. The time is almost always expressed in second. So in this case, rate of reaction will have the units mole per dm cube per second, or in case of gases, kilopascal per second, or Newton per meter square per second. So these are the units for the rate of reaction. So rate of reaction has unit of mole per dm cube per second, or kilopascal per second, or Newton per meter square per second. According to the law of mass action, so you must know about the law of mass action. According to the law of mass action, the rate of chemical reaction at any instant is proportional to the active masses or molar concentration of the reacting substance at that instant. So now see here, according to the law of mass action, what exactly the rate of reaction is. So the rate of chemical reaction at any instant, suppose after 1 minute, after 2 minutes, or after 1 hour, after 2 hours, so at that instant the rate of reaction is proportional to the active masses or the molar concentration of the reactive substance at that instance. Now see this graph also here. So at the left hand side, at the y-axis concentration is there, on the x-axis time is there, and we're plotted this graph for the that is change in concentration with respect to time of reactant. For a given initial concentration of a reaction rate is maximum at the beginning. Now see here this graph, if time goes on increases, the concentration of reactant goes on decreases. Initially the variation in the change in the concentration is sudden, but after some while, after some time, the change in concentration remains small, or it's steady. So for a given initial concentration, the reaction rate is maximum at the beginning, and the rate is becomes steady or decreases with time. This is because, now see here, why this graph is like this. This is because the concentration of reactant decreases with time. Okay, as we go ahead and ahead, the concentration of reactant decreases and concentration of product increases. Theoretically, infinite time would be required for a reaction to be complete, or for its rate to fall to zero. Means the infinite time is required here to becomes a zero here. The concentration of reactant to become a zero, it requires an infinite time. So, but the reaction rate becomes so slow after a certain time that for all practical purposes the reaction can be considered to be completed in a finite time. Since the concentration changes at every instant, there is no simple method of determining the rate of reaction directly. So the concentration of reactant changes every instant, every second. Therefore, there is no simple method for determining the rate of reaction directly. The concentration of reactant or the product is determined at various time intervals, and a graph of concentration against the time is drawn. A smooth curve. Now see this figure second will be obtained, and the slope of curve at any given time gives the reaction rate. Now if you see this graph, you will understood here that uh, we are going to determine the slope of these curves by plotting the graph concentration against a time interval. Now see here, initially the concentration of reactant, so this graph is of reactant, this graph is of product. uh, if you see this graph, initially the concentration of reactant is more. As time goes on increases, the concentration of reactant decreases, but the concentration of product goes on increases. So without decrease in concentration of reactant, there is no increase in the concentration of product for that reaction. Therefore there must be a change in concentration of reactant, then and then only there is change in the concentration of product. Now see here, so initially A is the concentration of reactant, A is the concentration of reactant, so I will write here A concentration of reactant, then X is the concentration of product. If you see here, so X is the concentration of product. Then after certain time there is a change in concentration of reactant, this reactant. Therefore how much is changed, then we can say A minus X, means initially the concentration is A, but some amount of X, that is product, is formed. If you minus X from A, some amount will be there, and that amount is nothing but the concentration of change in concentration of a reactant or concentration of A. So if you see this graph, reactant graph, now see here, so there is an A minus X, and this is X, means X is increased, and the concentration of reactant goes on decreases. So the slope here dx by dt, and the slope for the reactant is minus dc by dt for calculation of the change in concentration with respect to the time. So this is the basic regarding what is meant by rate of reaction, and how the concentration of reactant and the concentration of product changes. So next point is measurement of reaction rate. How we are going to determine or measure that is the reaction rates. The temperature has considerable influence on reaction rates. So temperature is the most important factor on which the rate of reaction mostly depend. Consequently, when a kinetic study is made of a reaction, temperature is maintained constant. When we are going to study a kinetics or kinetic of reactions, then we maintain a temperature constant in a lab. A reaction mixture of known composition is prepared and placed in a thermostat, a device for maintaining constant temperature. So thermostat is nothing but thermostat. It maintains the temperature constant. So we are taking a mixture of reactants. Suppose A is the reactant, B is the reactant. So when both these reactants are kept in a thermostat, after 10 minutes or after certain time, the temperature of both these beakers or both these flask becomes constant. Therefore they are put into the thermostat instrument. So a reaction mixture of known concentration is initially prepared and it is kept in a thermostat. A reaction can be quantitatively followed either by determining the decrease in concentration of reactant or increase in concentration of product with respect to the time. So there are two possibilities for calculating the rate of reaction. Either we can determine the decrease in concentration of reactant or increase in concentration of the product with respect to the time. The actual method used in finding the concentration changes with time depends upon the nature of reactant and product. So which method we are going to select, it depends upon the nature of reactant and product. A commonly used method is to remove samples of reaction mixture at a definite time interval, stop the reaction by chilling them or freezing them, and, analyzing the sample by titration. So actually the simple method is used for the determination of rate of reaction is that, so in that case, in that method, we are taking two conical suppose conical flask is there, we are taking conical flask. In that, from the beaker we are taking, suppose the beaker is filled with a reaction mixture, or it may be a stoppered bottle. So in that the reaction mixture is there, A plus B. So from the reaction mixture, after certain time, suppose in the initial case there is after 5 minutes the reaction is sucked with the pipette and it is taken into the conical flask, and in the conical flask we are adding ice or uh, ice water to stop the reaction instantly. So when the reaction mixture is taken into the conical flask, after adding ice into that reaction mixture after certain time, 5 minutes, and the same procedure is followed after 10 minutes, after 15 minutes, after 20 minutes, then the same. So these mixtures are then titrated. So this mixture at 5 minutes is titrated with titrated with the chemical which is taken into the burette. So after 5 minutes the reading is different, after 10 minutes the reading of the reaction mixture is different. So after certain time interval all the mixtures are taken and titrated with the chemical which is taken into the conical flask. So this is the simple method for determining the rate of reaction. Now see here what happened after that. Since a change in concentration occurs during the course of reaction, physical methods are also used to follow the reaction. So the different methods are also used for determining the rate of reaction. Variation of conductance of a reactant, refractive index, change in refractive index, or change in viscosity, or light scattering. So by use of these physical methods or calculating these physical properties, we can calculate the rate of such reactions. So the volume of gas evolved during a reaction is also used for determining the rate of reaction. In case of reactions in the gaseous phase, the total pressure is usually employed. If the substance under study is optically active, the reaction can be followed by determining the angle of rotation by use of polarimetry. Now see here, most of the time in objective this question is asked. So how will you determine the optical activity of the reactant? So optical activity is determined by calculating or determining the angle of rotation by use of polarimeter. So polarimeter is an instrument used for determining the angle of rotation of the reactants. Those molecules which are optically active, they show change in the angle of rotation by use of polarimeter. So these are the simple methods which are used for determining the rate of reactions. Next is an order and molecularity of reaction. So I think you know about what is order of reaction. So you may heard about first order, second order reactions, and the second is in molecularity. I think in the organic chemistry SN1 and SN2. So what is mean by SN1? So 1 indicates that it is a unimolecular, and SN2, so 2 indicates that it is a bimolecular. So the same term is here. So this is molecularity of reaction. So what is meant by order and what is meant by molecularity, we will see here. The way in which the rate of reaction varies with the concentration of the reacting substance is generally indicated by order of reaction. Now see here, what is meant by order of reaction? Why it is used? The way in which the rate of reaction varies with the concentration of the reacting substance is generally indicated by the order of reaction. How the rate is varied with the change in concentration is explained, or it is indicated in terms of order of reaction. Now see here, what is the definition of order of reaction? uh, the number of molecules or atoms whose concentration, if it is liquid and solid it is concentration, if it is gaseous it is pressure. The number of molecules or atoms whose concentration or pressure determine the rate of reaction is called the order of reaction. Means the rate of reaction is depends upon the change in concentration of the molecules. So how many number of molecules which are involved in the reaction, and number of molecules whose concentration changes during the reaction, so that number explain you or indicate the order of reaction. So in general, if it is experimentally found that the rate of chemical reaction is proportional to nth power of reactant A and nth power of reactant B and so on, so rate of reaction is equal to K into concentration of A reactant, concentration of B reactant. So concentration of A, nth power of concentration of A, nth power of concentration of B reactant. So if you see this definition, the number of molecules whose concentration changes during the reaction, these molecules determine the rate of reaction. So therefore is called as an order of reaction. So K is a proportionality constant, and the overall order of reaction N is given by, so N is equal to, now see here, Na plus Nb plus, if there are number of reactants are there, then we may add Nc, Nd, like that. So the N is equal to Na plus Nb plus dash dash dash. So now if you see this equation 1.1.4 and 1.1.3, so from the equation 1.1.3 is a rate equation. Such a reaction is said to be nth order with respect to A and nth order with respect to B and so on. So if there are two reactants are there, A and B, then the number of molecule of A whose concentration changes and the number of molecules of B whose concentration changes are determine the rate of reaction. In other words, the order of reaction is also the sum of all exponents or powers to which the concentration or pressure are raised in the rate equation. If you see this equation 1.1.3, so in the 1.1.3 the reactant concentration power Na and B, therefore we added Na plus Nb, and this Na plus Nb gives the order of reaction. So the order of reaction is sum of all the exponents or the powers to which the concentration or pressure are raised in the rate equation. So in the rate equation, the powers to concentration or powers to pressure are added, and that number gives you the order of reaction. If the reaction rate is proportional to the first order of the concentration of one reactant, then the reaction is said to be first order. So what is first order? When the reaction rate is proportional to the first power of the concentration of reactant, then that reaction is first order. If the rate is proportional to the product of concentration of two reactants, the reaction is said to be the second order. if there are two molecules are involved and the concentration of both the molecules are get changed during the reaction, then the order of reaction is second order. uh, if in a reaction only one substance is involved, then uh, it is written in terms of change rate of reaction that is equal to minus dc by dt is equal to kc raised to n. In this case, the order of reaction is n because only one substance is involved in the reaction rate. Another method of classifying reactions is in terms of molecularity. So initially, by use of order of reaction, we can classify as first order reaction, second order, third order reaction, like that. uh, the second method of classification of reaction is the molecularity. What is mean by molecularity? Now see here, number of molecules or atoms which take part in each step leading to chemical reaction is called the molecularity of reaction. So how many number of molecules which take part in each step, so that number gives you information regarding the molecularity of reaction. If you again read this definition, you will understood the number of molecules or atoms which take part in each step leading to a chemical reaction is called the molecularity of reaction. Reactions are called unimolecular, bimolecular. It is depending upon the number of molecules involved in the reaction. So what is unimolecular? If only one molecule uh, breaks into smaller parts, the reaction is called as unimolecular. If two molecules have come together before a reaction can take place, then the reaction is said to be a bimolecular. If you see this reaction, unimolecular reaction and bimolecular reaction, so Br2 gives two Br radicals, N2O5 gives N2O4, and half oxygen is get evolved. So these reactions are unimolecular because only a single molecule is involved in the reaction in that step. Why it is bimolecular? Now see here. So here methyl acetate and water, these two reactants are involved, and this reaction gives you acetic acid and methanol. Then such reactions are bimolecular because there are two molecules are involved in the reaction step. So H2 and I2 gives an HI. Therefore this one molecule of hydrogen and one molecule of iodine is involved. Therefore this reaction is a bimolecular reaction. In many cases, the order and molecular of reaction is same. So in some cases, or in many cases, the order and molecularity of reaction number is the same, but there is no necessary correlation between the two. So there is no correlation between the order and molecularity. If you see this example now, see here, hydrolysis of methyl acetate takes place according to the following equation. So this is a methyl acetate is hydrolyzed by use of water molecules and it gives acetic acid and methanol. So it is apparent from the equation that, so by if you see this equation or a reaction equation, then there are two molecules are involved. Okay, one each is methyl acetate and other is in water are required for the reaction takes place. But since the water is taken in excess, its concentration remains virtually constant. Means water is in too much amount, its concentration or the small change in concentration of water is not uh, taken into the account while studying this reaction. Consequently, even the reaction is bimolecular. So the reaction is molecular because two molecules are involved. The rate of reaction depends only on the concentration of methyl acetate, and the reaction should therefore be a first order. Such reactions are called as in pseudo first order. So if you see here, so what exactly it means to us, why it is called as pseudo first order. Pseudo means fictitious. So in this case, one molecule and two molecules. So two molecules are involved and we are getting a product that is acid and alcohol. So hydrolysis of ester takes place in presence of water molecule and we are getting acid and alcohol. So in this case, two molecules are there, therefore it is a bimolecular. But if you see the change in concentration of these two, only the change in concentration of ester takes place, and therefore The rate of reaction depends only on the concentration of this ester. Therefore, the order of reaction is not a two order reaction, it is only a first order reaction, though there are two molecules. Therefore, this reaction is known as a pseudo first order reaction. So this is what we have studied today in the first lecture. Now see here, what is meant by rate of reaction. So rate of reaction is nothing but change in concentration of a reactant or product per unit time is known as rate of reaction. If you see these two equations 1.1.1 and 1.1.2, so in 1.1.1 the rate of reaction is change in concentration with respect to time, that is minus dc by dt. So this dc is nothing but concentration of reactant, it decreases with respect to time, therefore we have written the negative sign there. In the second equation, dx by dt, x is the concentration of product, it increases with respect to time, therefore there is no any negative sign. According to this law of mass action, the rate of any chemical reaction at any instant is proportional to the active masses or molar concentration of the reacting substance at that instant. So how much active molecules or mass are there in the reaction center, then such active molecules determine the rate of reaction. If you see this graph, the concentration of reactant goes on decreases, but concentration of product curve goes on increases. So how to measure the rate of reaction? So it is determined by use of simple chemical titration reaction, and by use of physical properties calculation we can calculate the order of reaction. So what is meant by order and molecularity? So order of reaction is nothing but number of molecules whose concentration changes during the rate of reaction is called as an order of reaction, and molecularity is nothing but number of molecules which takes part in the reaction which leads to the chemical reaction is called as molecularity. So many times molecularity and order of reactions are same, uh, but in some cases, though there are two molecules are involved in the reaction, but only the concentration of single molecules get changed, then such order of reactions or such reactions are known as pseudo first order reactions, though there are two reactant molecules in the reaction. Thank you.